実はですね、日本語で話そうと思っていましたが、やっぱり無理です。すみません。これから英語でやらせていただきます。で、
Hello, everybody. I'm Zev.
And I'm Kevin.
And we're going to talk a little bit about how, for the past 7 years, we've been developing the same website with a Ruby on Rails code base, and the things we've kind of learned and experienced during this period. There's a lot to talk about, so there's too many stories and things to go into, so we've kind of tried to condense it down to a few points. But first, let's talk a little about what is I-know. Does everybody know what I-know is? みんな I-know 知ってますか？まあ、結構知ってる人がいますですね。よかった。Just in case you don't know, it's a product that's developed by a company called Cerego, and it is an online language, English language learning platform in particular, although we do help people learn Japanese too, and also Chinese. It is basically, we don't like to say it too much, but it's in some ways, the quick gist is it's a very advanced flashcard system. Basically, there's the technical term is a spaced repetition software. We are kind of the super version of that. And that basically means that we let you learn, know what you know, learn things faster, and see things before you forget them. We're missing the notes. And so just before we go into that, let's talk a little about the history of what we've done with Cerego. In 2007, Cerego released the ino.co.jp website to the Japanese public. And around 2008, we then showed this often about our development style and what we've done at the RubyKaigi 2008. In 2009, we decided we wanted to be a little bit more focused around the world. So we rebranded the whole site and called it SmartFM, cutting out all of our front-end web code, taking little bits and pieces, but keeping the back end, which we'll go into a little bit later. Then in 2011, we decided actually we weren't quite ready for that yet, so we went back and called ourselves ino.jp. We also started to charge a little bit of money for the service. And then around 2013, as the site was growing again, we decided that the ideas that we had in SmartFM that we wanted to keep, we were going to try a new strategy. So we have a site in Brazil called Cerego English to help Brazilians learn English. And then in late 2013, we released Cerego.com, which is focusing on declarative knowledge, but more so than just language. It's on facts like jazz, medical terminology, and that we have plugged into sites like edX and Elsevier. So let's take a quick look at what I-know looks like. This is right when you're about to start studying a site and you've actually done a bit. This is kind of what we call our memory bank. And you can see that this Kevin here has been doing a good job studying, and he has lots of little balls which are represented as vocabulary items. And some on the top right means that he has a pretty good knowledge of them. The stuff that's in the middle and the bottom, he needs to review a bit more. And that kind of gives you an idea of where you're going to work towards. Here's just the front page of the Brazilian site, just to give you a feeling that, yes, we actually have it. And here's the similar memory bank site, brain bank site for Cerego. And in this one, we're using images. So this person is studying Pokemon characters. But he hasn't been doing a very good job, so he has to study a lot more because there's a lot of red dots at the bottom. In addition to this front-end web-facing site, we also have, of course, mobile sites. So we have an iPhone app, an Android app, and we also have an application on the PS Vita. So from all this time and experience, there's a lot of things we've learned, and Kevin will now describe some of our core points.
Yep. So as I've said, we've learned a lot doing this website over this many years. So we just want to talk about 3 of those today that we think are really important if you're going to maintain a large website, especially in Ruby on Rails. So those 3 things are that sharing code is really hard. When you write your own custom solutions, you have to put a lot of effort into them. And over time, more than code, the people working on the code are going to change. So let's talk first about how we share code. So like Zev talked about, we have a very large website. But not only that, we have 3 very large web applications. And of course, while each one has its own characteristics, they obviously have to share a lot of common code. So how do we do that? So let's first talk about, within an individual project, how we broke up the code. So our app started as a single monolithic Rails 1 application. And we decided that we wanted to get ahead of this and not have a giant monolithic code base. So we split it up something like this, where we have two Rails applications, a front-end web app for running in the browser, and a web API that both our browser app and our mobile applications talk to. And then they have a shared core of libraries, models, and generally where most of our back-end logic is. So let's kind of take a look at how this breakup falls out. So most of our code is in the shared core on the far right-hand side. The left side is our web application, and then the middle is our API, where you can actually see the number of tests, which are the green bars, exceeds the number of code in API. So a very, very thin API. And altogether, it's about 200,000 lines of Ruby code, so not including ERB, stuff like that. So there's a lot of strategies for accomplishing this three-paneled split. And so there are a few ones you could do now, but which include like Rails engines and gems. But we did this quite a long time ago, and a lot of those things were not mature or didn't even exist at all. So we ended up going for a Git submodule that lived in our plugins directory. So while this did give us the split that we had, there have been some very large difficulties with it. Bundler really does not like this. We have 3 gem files. So we have a common gem file in our core, which houses most of our gems. And then the 2 individual applications also have gem files. But what this means is that if you change the common gem file, you have to go and push lock files for all 3 repositories, which makes updating gems very, very painful. Another issue is that a lot of editors and tools have a very hard time with submodules, particularly if your models are not where an editor expects them in the standard Rails file structure. And lastly, our deployment and Jenkins builds are much more complex because we can have the situation where, sure, our web applications test passed, but the core tests fail, so we don't want that to count as a successful build. And then, of course, deploying means that we need to have the most recent head of our shared core module and make sure that syncs up with the head of the web application or the web API. So although there have been problems with this, it has been allowed us to get out of the monolithic Rails solution, share a lot of this code, and move us more towards an API-driven website. So like Zev said, in 2013, we took what had become INO and split it out into 3 sites. But if you think about that, we already had 3 repositories. So if we have 3 sites now, it means we have 9 repositories, which is not very fun if you're now talking about pushing 9 gemfile.locks. So although this did let us get to these 3 sites very quickly, we've also had some problems with this. So with forking, what often happens is that we'll develop a feature for one of these sites that's cool and it's great, but we don't merge it back in right away, and things diverge, and it ends up the sites have very different feature sets, even though a lot of them would make sense if they existed on all 3 platforms. Rails upgrades are already pretty challenging, but if you've ever ported a Rails app from Rails 2 to 3, imagine doing it 3 times. Not very easy. And from the systems perspective, this gets pretty difficult because some of our apps end up being on Rails 2, 3, and 4 at the same time, which means that we have to support multiple versions of things like Ruby gems, multiple versions of Ruby, C extension, dependencies, and things like that. However, this has worked out in a lot of ways. So as I mentioned, we were able to launch 2 brand new websites in 2013 with a pretty small team. And a lot of that was because at the time we forked, everyone knew the code base. It was known working. It was solid. It was good. And everyone got up to speed very quickly. And it also meant that as the sites matured and changed, they could change without affecting the other websites. So if something made more sense for our site in America, then we didn't necessarily have to bring it back to Japan if it didn't make sense. So this is how we've been sharing code up till now. But Zev primarily worked on our switch to Cerego.com. So he's going to talk a little bit about some of the other ways to share our code.
So with the forks that we did, it gave me a lot of room to make some aggressive changes. The Cerego.com in particular has made a lot of changes that don't necessarily make sense anymore with the INO world. So some of the ways that I wanted to make sure that the work I was doing for Cerego could be shared back into INO and Cerego English. We have these kind of 3 ideas of using Git cherry picks. We use gems and engines. I would love to use branches and merges, but because Cerego.com has diverged so much, this would just be a merge conflict fest, and I would just give up. So when I worked on things like moving Cerego.com from Ruby 1.9 to Ruby 2.0 into 2.1, I was able to go through the core and make maybe 10, 20 commits and keep a list of those and then just apply cherry picks as a Git remote branch to the INO code base. And that would mostly catch all those situations, and I may have to make 1 or 2 small merge conflicts. This was particularly really easy to do when I changed out the background processing system that we'll hint at a little bit later on, where I changed that to rescue, and that was pretty straightforward. 3 commits, bring it over. Ideally, you don't really want to do this. This was kind of just a history of how our system is. If we had the time, and which we will be doing, is starting to carve out more and more of the core into gems itself. And then, of course, having a gem in a bundle file is much, much easier to share amongst everybody else than doing labor-intensive cherry picks. Also, when it makes sense, using a Rails engine for more complicated logic. So with that, though, 7 years is a long time. We're, of course, going to come up with our own solutions for things. Sometimes the solutions aren't there at the moment. So we have lots and lots of custom code for, at the time, gem management, lots of patches onto the older asset management solutions, our own custom access control, our own custom serializations to turn XML to JSON to whatever else we had. We have our own natural language parser, and we have our own mobile push notification. As a new developer coming in, usually, if they're fairly new, they're going, what's going on here? Why aren't we using bundler? Why are we not using the Rails asset pipeline? Why aren't we using JBuilder or CanCan or all these other different solutions that are common? Of course, 7 years, we would have loved to use it, but it wasn't there at the time. And then we're so busy working on product that we didn't take our heads out of the coal mine to say, oh, yeah, we should do this. So that's good of having fresh blood to come in and ask these questions. At the same time, as a developer in the team who's been there working for a while, sometimes it feels like, okay, these guys are kind of whining too much. The system works, it's not broken. Why are we going to waste our time with that? So it kind of requires a bit of empathy on both sides to not get frustrated for both sides of the team and to just look at it more naturally. In addition to our custom code, we have lots and lots of monkey patches. So the problem with monkey patches is it's great to solve solutions, but at some point you forget, is this actually us? Is it Rails? Is it Ruby? Especially when you do upgrades. Did they also provide the same solution now? So you have to kind of keep that in track. Luckily, from the beginning, we actually keep all of our monkey patches organized in vendor patches directory, so it's very easy for us to periodically go through and say, yeah, that's no longer needed. Rails provides a solution for like 2hash or 2set that we don't need anymore for our own custom forms. But customizations aren't all bad. They serve a purpose, right? At the time, sometimes the concepts aren't there in the Rails or Ruby environment, or they're not very mature. We have our own custom background system that we used for a while, and that was because all the other background tools at the time weren't getting a whole lot of love, or on the mailing list, people were saying, oh, it's all broken, and we just said, okay, well, let's look at what our needs were and implemented something that suit them. In addition, sometimes you need to own the code that you're working on. You have a specific performance requirement, and a gem out there doesn't quite meet it, so we have our own things for that at times. But especially for things like domain-specific code, like our natural language parser, which we call Cerego, that's something very specific to us. It's actually more close to the product, right? But with that, there's always a time, when new developers start asking all these questions, why aren't we doing it? There's a time to move on, right? When your custom solutions start breaking all the time because you're upgrading Rails, you're upgrading Ruby, you have monkey patches that are just built around private APIs that are constantly changing. So if you're patching Rails, in particular, we have some patches for how we deal with MySQL migrations. Those would break every time we do an upgrade. And so it gets to be maintenance that we don't need. But especially also, someone who does a custom solution tends to know the tool really, really well. And if those authors leave, then of course now we're kind of back to square one. So then it's always a good question about thinking about when we should start using more standard tools again. So the advantages of standard tools are, a new developer comes in, they're probably already familiar with it, so they can get up to speed much faster. There's a lot more documentation usually about it. And of course, if you spend time using these tools, you can also share back to the world with blog posts, other comments and things like that. But of course, there's always some of this custom code that's not core to your product that you want to share out. Maybe the better thing is to make your custom code become the standard solution. So you can open source those bits. And we have a few open source elements in our code base. Of course, the problem with that is open sourcing is easy to say, but it requires a lot of work to actually get it to become a standard and to promote it and whatever else. But it's always something good to think about. So with all these custom solutions, Kevin has a good story to talk about for.
Yep. So I'm going to talk about my favorite bug that I've encountered due to our custom sauce here. So let's talk a little bit first about how Rails works and how rack works. So you can write rack middleware, which sort of wraps the request and lets you change the body of it before it goes out. And we do indeed have some custom rack middleware, which most of the time works pretty well. So we'll come back to that in a minute. But as far as Rails goes, there's a very handy feature of Rails, which is when you send a SQL query to the database to construct an active record object, Rails will cache that SQL query. And what it will do with that is leave the results for you to be used again. So if you make the same query within the request cycle, you don't have to go back to the database. So this is great. This means that it saves a lot of round trip time. But of course, it's very important that this cache is cleared at the end of the request, or otherwise you would get stale data. Well, with our rack middleware, we forgot to close the body of the request, which normally isn't a problem, except it turns out the Rails team also likes writing rack middleware. And particularly, this line is in a piece of rack middleware, which is to say, when you close the body, make sure you clear that query cache. This never ran on our code, which meant that our cache was not cleared for weeks. So it was a great cache. It meant that once you went to the database, you never, ever went back. Yeah, I don't know how you catch this. I don't know, would you write a test that says, hey, if I hit the database and come back 3 weeks later, do I get the same data? It's a pretty weird test. So definitely be careful when testing your customizations, because you may end up having to get deep into the internals of Ruby and Rails. So finally, we want to talk a bit about what happens when people change. So over the course of these 7 years, we've had about 60 developers. And those 60 developers have changed our database more than 1,400 times. So needless to say, when people leave, a lot of that knowledge gets lost. Many of our database columns, we have no idea why they are there. Not only that, but your tests start to lose meaning as well. And finally, a lot of our well-designed code has gone pretty far awry. So let's talk about these 3 things. So when knowledge gets lost, you lose all sorts of workarounds. So there are lots of things where this doesn't work quite right, but everyone knows to do the right thing, so it's OK. We'll just leave it alone. And then those people leave, and no one knows what the right thing is anymore, or even there is a trick to know. Like I said, a lot of our data structure meaning is lost. Something that was very important just appears as a column, or something that once was useful is now completely gone. And more than that, a lot of dead code piles up. Tests as well have this problem. So we have a lot of test helpers in our code for common workflows that have been implemented 5 or 6 times with different interfaces and different bugs, because no one bothered to go and hunt down the old ones. We have a lot of tests that say, do this thing, make sure it returned 6, and if it didn't, that's too bad. Why should it return 6? No one knows. We just know that when it breaks, we probably end up just deleting that test. And then fixtures, too, rot. So a lot of our fixtures are inconsistent. They're no longer really representative of how data gets into the system. Foreign keys just point to the wrong tables or point to the wrong records. And in general, our fixtures are some of the most brittle parts of our tests. And finally, we have a lot of well-designed code that goes bad. So a class that had a nice single responsibility, no one knew what the single responsibility was. They just knew it had a cool name, and so that everyone sticks their own pet method on the class. And now it's not so well designed anymore. This means we end up with a lot of code duplication and things that aren't where they should be, or things that are already handled but end up getting re-implemented somewhere else. So all of this is pretty tough. This is pretty bad. So the question is, how can we deal with the fact that people change? Because people are always going to change. People move on to new projects, get new jobs, new people come in. So what can you do to avoid this? Well, there's a lot of things, but I think 3 of those are deleting that dead code, keeping everything up to date, and bootstrapping your new developers. So Zev's favorite pastime is deleting code, much more than writing code. So I'm going to let him talk a little bit about that.
So yeah, for the past couple months, I've been on a delete dead code streak. So in the I know code base, if we do a git stat, we have roughly 5.7 million lines of code. This includes HTML, CSS, through the history of the code base. But in addition to that, we have 3.3 million lines of code deleted. So we're a little bit over 50%. So there's something quite satisfying about having a merge commit for a branch that deletes 20,000 lines of code. It's not as good as a new feature, but it's pretty damn good. So what is the benefits of deleting dead code as opposed to just feeling good? Well, it reduces mental overhead. It's pretty terrible when you come into a project and you're doing some refactorings and you hit a bunch of files that you're refactoring and you find out, oh, yeah, we don't use that anymore. So you've just wasted time refactoring dead code. So get rid of it, right? Even better, if your code has tests on it, you speed up your tests. Right now, the I know code base takes roughly 40 minutes or so to run through on Jenkins. In the Cerego.com code base, we have about 5 minutes. So that was a nice reduction in speed from those commits. And of course, having dead code, removing the dead code makes it easier to upgrade because you're not spending time upgrading it. And we have source control, right? And if your tests are passing, and at least a couple other people have an idea what's going on, and they know that they don't need this code anymore, you shouldn't really be afraid of the code anymore. You can get it from your source control history, assuming, of course, people know that it is in the source control. So that's another problem I don't have a solution for. But if you know to look in the history, you can usually find it again if you need it. You may want to be a little bit careful when you're dealing with payments and authorization. So I would love to talk to anybody about their feeling about deleting dead payment code. So once you've deleted all this code, it makes it easier for you to be on an aggressive motion to keep everything up to date. Attracting a new developer, not so many new developers are going to be so excited about going, oh, great, I'm on a Ruby 1.8 code base with Rails 1.3. I mean, if the project's interesting and people want the job, sure, but if you want to attract a lot of people, it's nice to say, oh, yeah, at least we're on Ruby 2.1 and we're at least on Rails 4. We're working towards going to 4.1 and 4.2. So those help. It helps everybody, from that side. And then as a new developer, if you come in, it's nice to be able to get a computer. In the past, it used to be like a rite of passage to spend 1 week, 2 weeks, just getting your machine set up with all the various weird C dependencies we have installed, all the gems that we needed, and to actually get the tests to pass. We also have a very large developer database. So all those things took a lot of time. So we spent the effort to, like many other people have done, is make a combination of a Chef solo script with that can install on a Mac. It can also install on a Linux box or a Vagrant instance to basically, what became weeks is now basically maybe an hour or two to then be able to then go and be instantly productive in the code base. So all of these points are not just good for new developers, they're good for everybody. It's important to, while you're working on your product and things like that, to kind of every once in a while stick your head up out of the sand and say, oh, okay, what's going on in the world? I just delivered feature XYZ. Maybe I should think about what's happening with the rest of the world. And so it helps to consider yourself a new developer without actually having to leave the company. So from those points, we would just like to kind of reiterate the kind of main things we learned was, sharing code amongst your code base is hard, especially once it's amongst a lot of teams. You're having custom solutions that are not necessarily directly associated to your product requires a lot of effort to keep and maintain those. And then, of course, people change.
Yep. So in conclusion, code changes and people change. These are facts. So you've got to maintain the code. You your intention and logic, and all of that knowledge, so it's not just in your head. And I think that's it. We do have a coupon code, so if you want to try iKnow, or you have used iKnow in the past and you want to do it again, then please use this coupon code. And of course, if you want to be one of these new developers who helps us share the knowledge, then please let us know. Thank you.
We have 3 minutes for questions. Does anyone? 前の方に。
Do you know of any gems that would search your code base and check for dead code or methods that aren't used? Or do you have any recommendations of how to find dead code?
Well, I guess if you had 100% test coverage, that might help. I don't know if off the top of my head, but I guess I've kind of been at the company for a long time, so I kind of had a feeling for what was dead already, or what I really wanted to kill. So I took the advantage of getting rid of things that I didn't like at one point.
I think everyone has their pet code that they would like to kill. I certainly have mine. There are also gems for doing things like mutant testing, which normally mutant testing is remove a line of code, see if the test passed, and then if they do, well, either that was an untested side effect, or you weren't testing that particular piece of logic. Presumably, you could go ahead and just knock out entire methods, and if your test still passed, then it can't be that bad, right?
Thanks.
上の方に。
So it sounds like over the 7 years you learned about like some of the importance of paying off technical debt. Did you learn anything about how to convince non-developers like managers or whatnot that you need to invest in paying off technical debt?
Oh, good question. Yeah, I think, well, we kind of have ebb and flow cycles, and so while they're usually busy trying to figure out what the next product point was, we just took advantage of it. So we didn't really have to argue too much to say, hey, we want time to do this. We have in the past, like when we have bigger plans where we really want to change something, we've had to convince people saying, look, we want to make a big change to our learning engine to do these things, and that's going to provide benefits in the future. So that required a lot more going through. But in some situations, we had where some of the updates, like where we needed to do Ruby 1.9 to Ruby 2, we had potential business that was going to cause a lot of scale for us. So it's like, OK, well, we need to spend time to make sure that our system can scale. So we have to get done with Ruby 1.9 and things like that, which helped in that situation. But yeah, I don't have any secret magic thing I can wave at them except for saying, technical debt, your performance of your development cycle, right? It's going to decrease. New features are going to take longer and longer if you don't pay it off.
Yeah, I think I practice just-in-time refactoring, which is say, if I know something will take me a couple of weeks, I will extend that out so that I have time to refactor what I'm about to touch.
Okay. Okay, thank you very much, Mr. Zeb and Mr. Kevin.